Welcome to the next episode in our series where we create a 3D rendering engine from scratch. In this episode we will be learning how to extract the data from an object file and store it in a list for us to access. Our end goal is for a 3D rendering engine to look something like this, where we can move around, view it from different angles, all from a texture file and an object file. Last time we ended off with creating this new list and adding a basic triangle to our list. If you haven't seen that video, then go and check that out now. But we will be continuing on, and this time we will be creating a small piece of code that takes an object file and extracts all of the vertices and UV coordinates and puts it into a list for our program to then run. But before we write the code that extracts the data from the object file, we're actually going to go to the top here and create a new class called mesh. Now, what our code is going to do is for each object file that we have, it's going to create a new mesh and put all the triangle data, so the vertices, UV coordinates, all the transformations, the texture, all of that will be put into this mesh class for every object, so different objects can have different textures and can be moved independently. So here we're going to type, we're just going to copy this line here, and we're going to be putting it into this, and we're going to write public so that it can be accessed. Triangles, and we're actually also going to write now here vector2, and another vector2. This will be used later for our UV coordinates, which basically tells the program where on our texture can we find the right pixels to put on our triangles. So if you have a big texture with lots of different smaller textures or sides, say to a cube, then it's almost like mapping this texture onto our 3D cube. So each of our vector3 has its own vector2. And then we're also going to add down here public vector3 location and public vector3 rotation. And then we'll also write byte, and this will be an array, and we're going to call this texture. This will be used later. I'll make it public. So this will be used later by our program to store the texture. Now we're not storing it actually as a bitmap image because that's not very fast. We're storing it in a byte array because that can be read really quickly, making the whole program run faster. We will also write public int texture width and public int texture height and public int texture stride. The stride is basically in our byte array, which holds all of the color data. So you have red, green, blue, and alpha channels. Each of those are assigned to a byte. The stride is basically when we have our row of pixels, how long is that list of bytes. So for example, if we have an image that is 32 pixels wide, and then we times that by 4, so 128 bytes, because each pixel has 4 bytes for red, green, blue, and alpha. Sometimes there can also be padding, so spacing between these colors or pixels, And the stride basically says how long is our entire list of, or how many bytes there are in that entire row of pixels. And they'll be used later as well to work out which pixel we're trying to get out of our byte array. But now let's go back into our code, and we are going to be writing the code that actually extracts the information out of the object file and puts it into this list. So we'll write public mesh brackets, and then here we'll write string object obj actually path, and then bitmap texture. So we are getting our object path, so where it is on our computer or inside of the folder that this project's stored on, and then the bitmap texture, which will then be converted and copied into our byte array. So we're first actually going to be working on extracting the vertices data, and then UV, and then we'll copy the bitmap information into the byte array. So inside here we will write mesh equals new mesh. What this will do is this will create a new one of these where all of our object data will go into. Then below this we will write list vector 3 vertices equals new list vector 3, and we'll do the same for UVs, so vector 2, and we'll call this UVs. And so what we will do is, if I go and show you what the inside of a object file looks like, V stands for vertice, so you can see that each vertice line has 3 points, three numbers, and each number represents the vertices X, Y, and Z value. So this is a long list, and each vertex is, as you can see on the side, a certain number of lines down. This is like the vertices index or ID. And then if we go quite far down, so this object has quite a lot of vertices, then you'll see VT. This is all of the UVs. So you can see these now only have 2 points. So there's 2 numbers, an X and a Y. And then if we go all the way down, it's also important to know that these aren't actually like X and Y coordinates. You would have noticed that these are decimals. It's actually almost more of a percentage between how far away it is between each corner of the screen. So even if the texture were to change in size or aspect ratio, it will still have a valid pixel on the texture. And if we go all the way down, we'll find the triangles here, F. Now you'll notice that the triangles have these numbers divided, split by a little slash. What this actually is, if you remember early on when I was talking about how the vertices had a specific line that it was on, well, this is actually in this specific triangle, its vertex number 1 is on this line, and if we were to go to this line, 17,263, we will find a vertex. This here is that vertice's UV coordinates, and you can see that each triangle has 3 vertices and 3 UV coordinates, each UV coordinate assigned to a vertex. So what our little program is going to do is it's going to split all of those vertices and all of those UVs in order, but put them in this list, and then when we go to extract the triangle, we can instead just search through this list here, find that triangle's UV and vertice, and then put that into our list. And we'll do that for every triangle until the whole object is done. So that's what we're going to do next. We're going to go through each line in our object file, and we're going to check if it's a vertice with a V, a UV with a VT, or an F for a triangle face. And then we're going to split those off and then fill our list with that information. So we'll create 2 new lines, and we'll write for each string line in file dot readlines object path, run this code. So this is going to go for every line inside of our object file. Over here we're going to run this code, and we're going to have a variable, a string, with that line's information. And then here we're going to write if line dot starts with V with a space, run this code. So if our line is a vertice like we saw earlier, run this code. Else if the line starts with VT, another space, then run this code. So if it's a UV, and then finally else if our line starts with an F, it's a face, and we'll run this code. And so if you looked back to our object file, you'll notice that all the vertices were first, then the UVs, and then the faces last. And this is actually really useful because it means that the vertices will be filled first, then the UVs, and only once these two lists are filled will the faces start to be loaded. And if you remember that the faces is just a location of where it can find the vertices and UVs, if these are empty because the faces were the first in the file, it wouldn't work. So it's actually quite useful that it's ordered vertices, then UVs, then faces. So let's start with vertices. String array parts equals line.split by space, because inside of the object file, each vertice, each line is split by spaces. So the x, y, and z values for this vertice is split by spaces. Then here we're also going to write string options, string split options dot remove empty entries. So this will remove all of the spaces out of this array because we only want the values. Here we're going to write vertices dot add new vector 3. I'm going to hit space, and then we're going to write parts 1. We're also going to write float dot parse part 1, part 2, and part 3. And so what this is going to do is C# arrays actually start at an index of 0, because this here will still include the V. So we'll skip past the V, we'll go to 1, which is the second item in the list, and this will be the x coordinate, so we'll add that, and then the y, and then the z. So what we're doing is we're creating a new vector 3, and we're giving it each value, so its x, y, and z value is going to be this vertice's x, y, and z value. And we use float.parse because this is still a string, and we want to get the number value from it. So this will go through the file, and for every vertice that's inside of it, it's going to split it up and create a new vector 3 and add that to our list. So we're going to do the same for the UV coordinates next, and then we'll combine them all together with the face. So we'll start with the UV coordinates. So over here we're actually going to do the same thing over here. We're going to split this line up, this UV line, into its different parts, and then here we're going to write something very similar. We're going to write UVs dot add new vector 2 and then we will do float dot parse parts item 1, and then we'll do the same thing over here for item 2, except over here we're actually going to write 1 minus this. This is because if you remember that UV coordinates is just like a percentage almost, it's not an actual coordinate of where to find that pixel or where to find that vertice on the texture. So what we can do is we can invert it by having 1 and subtracting this value from 1, because the object's UVs are inverted for our program. And then we just add them like we did with the vertices. We add all the UVs to our list up here. And finally for the triangles, what we're going to do is we're simply going to, for each triangle, we're going to split it up again, and then we're going to get the vertices index, and we're going to find that in this list, and we're going to take that vertice and put it into our meshes triangle list as the first one, and then we'll do it for the next, and then the UVs as well. So let's do that for the triangles. So for the face, we're going to do the exact same thing, split it up, and then here we're going to write f parts.length is equal to 4, run this code. And we do this because not all faces and object files are triangles. Sometimes, like in other apps such as Blender, they can have bigger shapes with more vertices, such as a square, and our program can only handle triangles. So we're making sure that each line only has this f for face, vertice in UV1, vertice in UV2, and vertice in UV3, and then we know that it's a triangle. Now if you're creating your object in Blender, for example, modeling your object in Blender, when you export it as an object file, there is an option to triangulate it, so that there's no faces made up of more vertices than 3. And then in this we're going to write int the index equals new int 3, and we're going to write int another index, and we're going to call it UV index, and the same thing. Now what we're going to do is we're going to take, because each of these parts in the object file, it looks something like this. You have the vertice index slash the UV index. So that's what it looks like, and then you will have 3 of these like this, and then the F. So what we're going to do here is we're going to take each vertice in order and put them in this list, each UV in order and put them in this list. And it's set up this way because each vertice has its own UV, and so we do things in order so that item 1 in this list will be this, and item 1 in this list will be its pair UV. So over here we're going to write for and I equals 0, 3, yep, because there's 3 sets of vertices and UVs. We're going to run this code. Inside here we're going to write string array indexes equal to parts I plus 1, because we're actually going to be skipping over this F in the beginning, dot split, and then we're going to be doing it with a slash, and then yeah, like that. So we're creating a new array of string called indexes, and then we're going to be splitting this current section. So we're working on vertice 2. We're going to be splitting it by the slash, because we remember we have the vertice and then the UV, so we need to split the vertice and the UV and have them separate. So we're going to split that, and we're adding 1 because we're skipping over the F. And then over here we can write this, so v-index dot I equals int dot parse indexes 0. So we're getting an integer from the string again, and then it's inside of the object file, it's split with the vertice first and then the UV. So over here, splitting the slash, so now we only have the vertice and the UV separate inside this list. Because the vertice is always first, vertex actually, vertex, we'll be getting item 1 in this list. And we'll actually be subtracting 1 from this. And this is because object files have the very first line as 1. So if we want to get to vertice 1, that will be on line 1. But in C#, arrays actually start at 0. So while in the object file, vertice 1 may be on line 1, in C#, vertice 1 is actually in index 0. So we're taking 1 from that. We're going to do the same thing for the UV index. And we'll make this a 1 because we're getting the second item in the list. And yeah, that's it for the for loop. Now we're going to go here, and then we're going to write mesh dot triangles dot add 2 brackets, and then we'll write over here v index 0, v index 1, v index 2, and if you remember up here we have this list of vertices, what we can actually do now, we can take this and we're going to get, because we know now the index of our vertex here, okay? So our vertex 1, 2, and 3. We're going to find our vertex in this list with that index. We're going to do this, square bracket like that. Do the same thing over here. And the same thing over here. And so now we have all of the vertices, because in our mashup here we have vector 3, vector 3, vector 3 for all the vertices for this triangle. And we'll copy this and we're going to do the same thing but for the UVs. So we're going to write here UVs, 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 and then over here UV, 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 and there it is. We are adding to our mesh this triangle over here, and that triangle is made up of its vertices and UVs, and we are getting those UVs and vertices from the list that we made early on with the indexes that we had. And so that's pretty much it for this, the extraction of the vertices and UV data. Now we'll quickly just set a few more things, such as the texture, and then we'll finally return this mesh. So we're going to start it by just taking our mesh again, and we're going to write dot texture height. This will be equal to, here we have our texture, and we can simply just take our texture and write dot height, and we'll do the same for the width. And now the tricky part is copying over this texture into our byte array. We're gonna write this bitmap data texture data equals texture, this texture over here, dot lock bits. Now we're going to write new rectangle, 0, 0, starting at 0, 0, texture width, texture height, pixel format, and then we're also going to write over here image lock mode dot read only. So this is basically locking our texture, so now we can only read from it, and then we're going to copy that read only data to our byte array. So over here we're going to write mesh dot texture equals new byte array, and we're going to set this array's size to our texture data dot stride. Remember from earlier, this is how long that each row is in terms of bytes, because of padding and stuff. And then we're going to times by our texture's height. And then we're going to write down here, change that to a lowercase t, because this is lowercase t over here. Then we're going to write down here Marshall dot copy. This is just a really fast way to copy things. Texture data dot scan 0. So this is basically a pointer in memory, location in memory, telling us where we can find the start of this image. And then here we're going to write mesh dot texture, and then here we'll write 0, and then we'll write mesh dot texture dot length. And so this copies really fast everything from our texture into our byte array. So we're starting at the start of our texture in memory, and then we're copying it over to our byte array, and we're going from the beginning all the way to the end. And then we're also going to write here mesh dot stride, mesh dot texture stride equals texture data dot stride. And this is, like I mentioned earlier, on how long in bytes each row is in the image, which we'll need later on. And then we're going to unlock the bits. Up here we lock the bits to read only. We need to unlock them. So we're going to write texture dot unlock bits, texture data, and then texture dot dispose. This just gets rid of it from memory, so it's not taking up space. And so now we're going to go down here. We're going to write return mesh, and then up here we're going to write extract mesh from obj, and then up here we're going to make this public so that we can access it. And now we're going to create a new list. So we're going to make a list mesh scene meshes equals new list. So this is going to store all of the objects inside of our scene as a list, so that we can go for each object, for each of their triangles, draw them, which is what we're going to do down here. Before we do that, we're going to remove this line. We're no longer adding in triangles manually. And here we're going to write for each var mesh in scene meshes, run this code, and then here we can write var triangle and mesh.triangles, and that fixes all of our issues. So what this code is going to do is it's going to get an object, a file path, and a texture. It's going to extract all of that data, put it into our mesh, and for each object we have a list of meshes. We're going to make this public so that it can be accessed. And then for each one of those meshes, and each one of those meshes, and then each one of their triangles, we're just going to draw it. We're not up to using the UV yet, so that's just going to sit there, but we will eventually get to texturing the triangles. For now though, we'll just leave them as red, and we'll try this out. Now I'll leave in the description a link to download a car and car texture files. Drag those into your folder, your project folder, and change the build action to content and the copy to output directory to copy if newer, and do the same for the texture. So now in our code, we're going to go up here and we're going to write scene meshes dot add extract mesh from obj car dot object, that's our car path, and then we're going to write new bitmap car texture dot png, and that's it. Now also here I forgot to actually put these above these two lines here, because if you remember, this line over here removes the texture from memory, and we can't read from the texture when it's not actually there anymore. So we need to make sure that these two lines are above texture.dispose. Now let's give this a run. And here you can see the car being displayed. Currently it's still in red, no textures, but there are the 4 tires. There's the front of the car, top of the car, and yep, so it's working. So next time we will be doing camera movement, object movement, and rotation, and potentially starting on texturing our objects, and then we'll continue from there.